In this last video for the chapter, we're going to talk about geometric probability. So the probability of an event is the measure of the likelihood that the event will occur. So that just means what probability is. So when we find geometric probability, we will set up a ratio that involves a geometric measure such as length or area. So I wrote out, you're going to be using one of these. So if you're dealing with length of something, so like this number line, we're going to use this first part. So we're doing the part out of the whole. And if we're going to be dealing with area, so like in a 2D figure, so what we've been talking about with a shaded area, if we want to find out the probability of it being in a certain section, then we're going to do the partial area over the total area. And then when you divide it, our answer will be a percent. All right, so when we're looking at this number line, and we want to find the probability that a point is chosen at random on this segment, and if we want to see what is the probability that it's going to be on segment RS. So we want to basically do the part out of the whole, and when we're looking at the segments of P to Q versus R to S, RS is the part, and segment PQ is the whole. So next we need to count them to see how many spaces there are between it. So if you remember from before, we should probably do little bubbles. So for my RS, I'm going to go 1, 2, 3, 4, 5, 6. So there are 6 spaces for RS. Next for the P to Q, let's go on top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's out of 10. We can reduce this. So that would be, divide both by 2, that would give us a 3 out of 5. But even still, we want a percent number. So in your calculator, you're going to take 3 divided by 5, and we get 0.6. Now remember that that's not a percent number, so we need to move the decimal over 2 places. So 1, 2, and that means that this is 60% is my final answer. All right, we're going to practice doing this now with area instead of the length. So let's start with these 2 rectangle ones first, then we'll go back to the very first one. So in the one over here in the upper right corner, we want to do the shaded, so the partial area divided by the total. So that would be the shaded divided by the whole area. So to find the shaded area, and this one we don't have to subtract anything, it's just 3 times 9, it gives us the 27, and then 4 times 6 gives us our 24. So our shaded is 27 plus 24, which when we add that we get 51. All right, so then the whole area, then we need to look at this 10 and the 45. So 10 times 45 will give us the whole area. So when we will multiply that, we get 450. So now we want to divide that. So we're going to take 51 divided by 450. And in the calculator, we're going to get 0.11333. But remember, we got to move the decimal over 2 places. So it's going to be 11.3%. And we're going to just round to 1 decimal place. That's how it's going to be on the test. All right, so for the next figure down here, again, we're doing the shaded over the whole area. All right, so the shaded area in this one, we need to find some different pieces first. So remember, we're going to have to find the total area and subtract out the white area. So for our shaded, we need to find the total area. So our 12 times 5 will be our total area. And I need to subtract out the white section. So 8 times 3. All right, so the bottom for the whole area is going to be my 12 times 5. So let's go ahead and simplify that. That means 12 times 5 is 60. My white area, the 8 times 3, gives me 24. So when I subtract that, I get 36. All right, then for the rest of my fraction, 12 times 5 again is 60, so I can carry that over. So my shaded area is just 36. The whole area, though, is 60, so when I divide that, so 36 divided by 60, I get 0.6. And that's similar to what we saw before. We got to move the decimal over 2 places, so we really have 60% is how much the shaded area takes up of our whole figure. All right, so going back up to this very first one, there's an extra number that I need to give you. So the side length is 10.17. you're either going to be given the apothem and a side length, or the apothem and the perimeter, because those are the two pieces that you need to find the area. So again, we want to find the shaded area over the whole area. So let's individualize it a little bit better. Let's find the area of our polygon. So we're going to take our 1/2, our apothem is our 7. The perimeter, we need to take this 10.17 and multiply by our 5 sides. All right, so let's go ahead and do that. And when we multiply that all out, I get 177.975. All right, so then if we want to find the perimeter of, or sorry, not the perimeter, the area of our circle, it's pi r squared. So pi, our radius of the circle, if you notice, is our 7. So I'm just going to write this as 49 pi because that part I can type in my calculator and I don't have to worry about rounding. All right, so for my shaded, remember we need to find the shaded over the whole. So my shaded, I need to take the whole of my pentagon and I need to subtract out the circle section. And when I subtract those two, then I'll be left with that extra part that's shaded. Okay, and then the whole area is the pentagon because that's the outside shape, so that's my 177.975. So let's go ahead and subtract that on the top, and now I can type in 49 pi and subtract it, and I get a 24.037 if we round that over the 177.975. When we divided that in the calculator, we get 0.135. But remember, we have to move the decimal over 2 places. So that's going to be 13.5% is how much that shaded section takes up out of our total shape.